Welcome to the Week 3 lecture for QSO-600 Operations Management. This week we are going to provide a basic understanding of how quality is interwoven with our operations. So we do not focus solely on the quality of our processes, but also with the quality of the design and the quality of our understanding of what the customer wants. In many cases, I've seen where organizations will focus solely on one aspect. In many cases, the quality department of a company will only focus on how well we have processes to do things. Well, as you're going to see, quality is more than just the processes related to getting things done. We're also going to have a more holistic view based upon a concept called quality function deployment, which is the first part of what we're going to do in discussing how we can apply quality fundamentals to our operations management design. In this presentation, I'm going to cover briefly quality in operations. I'm going to briefly talk about what Deming and Ticcione and a few others talked about when we talked about quality with an operational aspect. And then we're going to roll directly into quality function deployment. This is a tool that we use to align what the customer needs and wants and expects with the company's ability to provide it. And it's going to also tell us how we're going to provide it as well. I'm going to give you some basic concepts over service design, and then I'm going to discuss two tools that are used quite a bit in service design. First one is a service process matrix, which allows us to map out how we're going to provide a service, which also allows us to identify the tools, processes, procedures, supporting infrastructure, things like that. And then we're also going to talk about service blueprinting, in which we're going to map out a service to identify how it's going to roll out, how it's going to flow to the customer. These two things are things that I've used quite a bit when I design services within the aspect of what I do. And hopefully it'll be something that you'll be able to find use in when you're doing your project, if your project is service-based. So notice that some of these can be used in manufacturing and service, between the two. For instance, quality function deployment, QFD, can be used in both services and manufacturing. I have found this usually used more in manufacturing than in services, but it can definitely be used within services with a little bit of modification. And the service tools, like for instance, service process matrix can be used. I've seen Six Sigma for manufacturing uses a service process matrix type tool. So just keep this in mind and be open to the fact that these tools are not solely for service, not solely for manufacturing, but can be used back and forth. So when we talk about quality in operations, Deming talked about three general areas of quality. You have the idea, which is the voice of the customer's wants, needs, expectations. We have the voice of the engineer, which basically is the design. How do we interpret what the customer wants, needs, and expects into something that we can create? And then we have production, it's the voice of the process. How do we bring this design to life? Now, Deming curiously stated that you can have a great idea and a great design and have poor production and not have quality. You can also have an idea that's not well understood, execute it with a great design, and have great production, and have a product that the customer does not want. And vice versa, you can have a product, have a very good grasp of what the customer wants, needs, and desires, design it flawlessly, and then fail on the production side, and you will have a product that is acceptable to the customer, but has flaws, like a car. So one thing that I want you to remember is that for a quality organization, to be truly quality organization, all three of these must be present. And you don't necessarily maximize or optimize each of these individually. As you're going to see with QFD, you need to optimize how the idea relates to the design, and how the design relates to the production of the product, and how the production relates to what the customer is going to receive. That's very important. In many cases, I've seen where organizations will maximize the parts without understanding the interactions. Like, for instance, let's say you create a design of something that's very hard to produce, but you produce it anyway with a high cost. You may produce a part or a product that may be too expensive or too expensive to maintain. I see this a lot in defense, where we will get a set of specifications which represents the voice of the customer. The customer's done our job of telling us, this is what your little tool needs to do. And we do all the work to get this great design, and then we produce it, and all of a sudden we have a very expensive product that, as a result, the customer goes, wow, it does everything I need, but I can't afford it. Or you may have a production, you may have a very good design, but it's hard to produce. So you may produce it very well, but now it's too complex. So now the customer does not understand how to use it. It may fit what the person wants to do very well, but maybe too complex. And once again, you may have a very complex idea. You know, the customer gives you all these specifications, and you design it and you produce it, but it's so complex, the customer goes, well, I know it's something that I could use, but I have to find a use for it. So you have to look at the interactions of all three of these sections. I like to call this the quality triad. But you can call it whatever you want. Just realize that each of these three sections has to be optimized based upon the interactions between the three. And this is important, this little blue box on the side here, that all the customer knows is what the organization offers them. So let's look back at when the car was invented. No customer ever said that they wanted a car. All they knew was that they wanted a better mode of transportation than the horse. So when Ford and all these other companies started to make cars, they didn't say, hey, what kind of car do you want? No, they had to try to understand what the customer needs and wants. So the organization's job is to define what the customer knows, needs, and wants, and then provide a product that symbolizes that. And that is where the idea provides value. So it's very important to remember that. So quality function deployment. This is a tool that was developed in 1966 in Japan to address what they viewed as an increasingly complex design. As we began to create more and more complex things like computers and faster cars and very complicated airplanes, they began to realize that it was becoming very complex for the current tools that they had. So they created what's called quality function deployment to give them a tool to help them design customer satisfaction into a product. So QFD allows for the design of quality in a product based upon customer requirements, which, if you noticed earlier, was the voice of the customer, design technical specifications was the voice of the engineer, and competitor capabilities, which is the voice of the competition. Now, you don't see that on the other block, but basically the voice of the competition is an environmental variable in which you have to make sure that your product will have a place in the market for you to be able to sell it. Part of QFD is understanding the competitor's capabilities so that you can both be competitive with that product and also provide a product that nobody else may be providing. This is very important. Yeah, we can just leave it at that. So it's very important that you understand the voice of the competition. And this goes back to your value proposition. Your company may be niched for, say, high cost, high quality. Well, if your competition is also high cost, high quality, then you are directly competing with them. But if they may be like low cost, low quality, in which case it may be easier for you to create a niche of customers that would find your product more favorable. Obviously, if they're low cost, high quality, you've got problems. But this goes back to your brand and your value proposition. I have a lecture on branding. I'll see if I can maybe link this in the classroom during the week that kind of explains how value propositions work. And this is an important part of understanding how you compare to the competition. And this is also a design variable also that you're going to use in QFD and in other types of designs, so you understand that you create a product that fits your product categories. You can use certain tools. I'm going to talk about one later on where you can map all the competitor products and your products on a 2x2 grid and try to understand the market saturation for a new product before you decide to build something that the customer may want, but you're going to be competing in a saturated market. That's outside the scope of this discussion, but just remember that's a very important part of operations. Make sure that you should be making the product, because sometimes you may, and QFD helps with this. Sometimes you may have to say, okay, we may not want to go high quality. We may want to go, just good enough quality and lower price to move into another niche. Okay. So, and the tool also encourages collaboration between all entities responsible for the product design. If done well, I've seen instances personally where an operations manager using QFD can use this to run the design of a product and align it to the operations. It's a very powerful tool when done correctly. Unfortunately, I've seen a lot also where they'll just go through the steps, and each function within an organization will just maximize their part of the QFD without understanding the interactions between each of those three elements, or they may just ignore the competitor altogether. Sometimes there's a bias where they think that their product competes better than it actually does. But if done well, QFD can be very helpful in kind of aligning every operations aspect into the design of a product. So there's basically 7 management and planning tools. There are other ones that you could use with QFD. Six Sigma has some pretty good tools that works with this. I'm not going to list them all, but I'm just going to go over the 7 main ones. So an affinity diagram is very good for taking a whole bunch of ideas and sorting them into relationship groups. So let's say if you do a brainstorm, you have like 30 ideas that you come up with. An affinity diagram can be used to find relationships and like use clusters, create clusters of ideas between all these different factors that you bring up. And that's useful because if you're going through QFD and you have to go through a bunch of technical requirements and things that you think the customer may like, it's sometimes best to kind of organize them into relationships so you can best understand how your capabilities align. And if you use a tool to kind of show where your product fits, sometimes an affinity diagram is very useful for that. A relations diagram shows us cause and effect relationships between different aspects of a complex system. You've probably seen these before. These are basically where you have you may have, like, on one end you may have a cause, and then you may flow through a bunch of effects, and then you would show arrows to show the relationships between each of the possible effects as they flow through to an end state. Or sometimes it's just static, where you may have it in the center. I've seen this also, relations diagrams where you may have a basic concept in the middle, then you'll show cause and effects within different customer desires or different technical aspects to show, like which one comes first, which one impacts the other one. So I'm not going to show them here. You can go on, I'm pretty sure Google has relations diagrams. I run out of time to make an example of each of these. But if there's enough request within the class, I may put up an announcement to kind of go through all of these. So a tree diagram decomposes broad categories into finer details to move from broad to narrow subjects. This is important. Sometimes you hear these called decomposition diagrams, where you have like for instance, let's say you have a car and you want to decompose it to its finer parts. So within a cognitive systems view, you may go, okay, car, then you may go, you know, drivetrain, fuel system, brake system, steering system, fuel system, and then you start to break them down. We call that a decomposition because it answers how something works. Now, the opposite of that is called an abstraction diagram. And what that does is we work up from a whole bunch of broad category, bunch of fine details to work up into different systems so that we can build up to a final product. And we use this in design, so when we're finished with the design, we may decompose our design down to the basic parts, and then we bring them back up to see if they all come back up and they do as they're supposed to do. So an abstraction diagram answers why. Like for instance, if in the bottom we have a tire, well, why do we have a tire? A tire is part of the steering system. Well, why do we have a steering system? And then at that point you go up to the car, but then you may have, between there you may have a specification for being able to control the direction that the vehicle goes. So then that would be the requirement that would go to the car. So the car would be the top level and you'd have all your requirements below that. Then you flow your systems below it. That's how you would create the tree diagram or the decomposition diagram. And then you would build it back up. Let's say you add something to the car. You may build those things that you add back up to see where it fits within the design, to see if it's suitable for the design. Once again, if you need any examples, I can probably find some for you. A matrix diagram, you've seen this before. Shows a relationship between 2 to 4 variables to highlight and illustrate key information. It's a general matrix. A general matrix is one on one side, one on the other. You can split up the squares inside to add variables. I do that sometimes. And there are 3-dimensional matrices where you could add, I think it's 16 variables, don't quote me on that, but you can add a whole bunch of variables. That's when you start doing modeling. That's when I usually like to use software for those kinds of things. But a general matrix diagram is basic, shows relationships between 2 to 4 variables. Very simple. Matrix data analysis is something that's used to mathematically analyze all the data in a matrix to find mathematical relationships between the variables. Simple enough. An arrow diagram is something that you've probably seen. It's basic order of tasks in a project or a process, like a flow chart. Okay, and the process decision program chart, it's similar to a FMEA, failure mode effect analysis. It systematically defines what might go wrong during development. So you would have the processes go left to right, and interjected inside it you will have a decision matrix where you would say, okay, does this switch turn on? Well, what if it doesn't? Okay, you would have a little thing that comes down and says, go back to square one. I use process decision program charts a lot when I do problem solving trees. So when I design ways to help people solve complex problems in a system, that's what I use the most for. You've probably seen them before. Sometimes you hear these called decision trees. It's pretty much the same thing, except for these are for processes. Decision trees, decisions are a type of process. But this is more for like general processes, like if you punch the widget and the widget is the wrong size, what do you do? Okay, this is how you create a decision chart to kind of understand what needs to be done if something does not go right. So the House of Quality is the core part of the QFD function. And the House of Quality is what I've used to drive creativity, to drive understanding between all 3 of those little quality triad sections. So real quick, it's a general matrix that we have on the left-hand side, voice of the customer, and then we have the competitive competitive evaluation, where we evaluate how the competitor stacks up to the customer requirement priorities that we determine based upon what we understand the customer's priorities are. Then we have the technical requirements on the top, the interrelationships between the technical requirements. It helps us to understand how the technical requirements affect each other. That's an important part. So all of this goes into a relationship matrix where we compare the voice of the customer to the technical requirements. And on this end, we rank the requirements. Then at the bottom, we have the technical requirements priorities. So we rank the technical requirements, and we rank the customer requirements. And we use this to determine how we should best design our product. Once again, it's a very effective tool. There's quite a few tools involved. The book actually does a pretty good job of going through this. So it has some pretty good diagrams in there. If you want something that goes through this in more detail, there's a lot of stuff on the internet. But let me know if I can help you with this while we're in the class. So as it says here, it aligns customer needs and organizational capabilities. Before we want to create something, we need to know what the customer wants, needs, and desires. Once again, they only know what we offer them. And then we also understand, what can we create? What are we capable of making? Do we want to make an iPad, or do we want to make a general TV screen that does nothing? Do we want to go high end, low end? Where do we fit? And during this time, we understand how the competition relates to our design, so that we can find out what niche we want to design based upon our value proposition. Then, of course, we create our priorities here. So first step we do, determine the customer requirements. This is the voice of the customer. We list all of the factors that the customer wants in the product on the left-hand side. Okay. So this step also relates product features to the organizational value proposition later on in the decision. You're going to see that in a minute. So the voice of the customer. We want to rank, understand what the customer is looking for. We don't rank them yet, but we will be ranking them. And then we list them here. Then the next step, the technical descriptors. We're going to say, okay, what do we need to design in the product to meet the customer requirements? And we rank them all here. And then we're going to create a relationship matrix to basically compare, make sure that each of the customer's requirements are addressed by a technical requirement. So what you'll see here is you'll see X's across here. Sometimes people use 1, 2, 3. Sometimes they use numbers. Sometimes they use like circles and squares, varying upon the requirements. So basically, this will tell us the technical requirements and how they stack with the customer requirements. This is a very important part here. And that's only the first part of this matrix. Now, at that point, we're going to understand the interrelationships between the technical requirements. And it's kind of, I have an example of this in a minute. It's a weird looking matrix where basically it's like you compare like 1 to 2, then 1 to 3, then 1 to 4, then 1 to 5, and so on and so forth, to help you understand how each of these technical requirements relate to each other. And this is important because when we start to look at technical requirements, we may go, oh, well, this one isn't really being used, but it's a requirement in several interrelationships. So we may decide, okay, we may need to keep this requirement in our design for whatever reason. It helps us to understand the technical requirements better. So we assess the competitor capabilities next based upon the voice of the customer. So what we'll do is we'll prioritize the customer requirements based upon how we understand the customer's requirements. Then we will do a competitive evaluation based upon how our competitors compare to these requirements. And I've seen this I've used this with perceptual maps. That's in the textbook. A perceptual map is basically it's a chart where you have a four quadrant grid. Sometimes you may have multiple. It just depends. But this is how we plot multiple products on a grid to determine like market saturation, any opportunities within a certain market, certain threats. A lot of times, sometimes you'll see arrows added to these to show movement within a quadrant. Sometimes companies may go on a quality kick. So we may say, okay, these guys are trying to go from low quality to high quality. So I like to use perceptual maps to help me understand this, so we can better rank the competitive evaluation of the customer requirements. And step 6, determine the priority technical requirements based upon the voice of the customer and the competitor capabilities. Here's where we determine where does our advantage come from. So and hopefully our advantage relates very closely to the top customer requirements. If not, then we need to look at how to improve our strategy. Sometimes you use marketing, sometimes you drop the price, make it more, there's different things to do. But this basically allows us to understand how our requirement priorities stack up with both the competitor and the voice of the customer. So this is what one looks like when it's filled out. As you can see here, you've got a bunch of customer attributes, okay, and a couple measures here. And then you have our design matrix, our specs that we're going to design to, and of course you see the check marks here. You see X. Once again, it just depends on how you want to rate them. And then here you see, like for instance, between these two, there's an X there. So there's no interrelationship between energy to closed door and closed force on level ground. There is a relationship between energy to closed door and energy to open door. So there's a relationship. So you show the relationships here. This is good because now you can go up this row, see, wow, there's 2 relationships here, and there's 4 where it's not related at all. And you can look, so that's how you can read these. So, and then customer perceptions on a scale of 1 to 5, we just map them out. This is how the competitor rates. So our car A and B. So this shows us here, they use a scale of 1 to 5, how the customer perceptions rank, we're number 1, so that's good. It could be where 1 is good and 5 is bad, or vice versa. So I'm going to assume that 1 is good. So we're very good here, we're very good here. We're not so good on this one here. So it doesn't kick back. So our doors do kick back. So this shows us here how we rank compared to our competitors. So, and then you have your targets here for design. Now, service design. I'm going to go over service design real quick. And once again, a lot of these tools here can be used in manufacturing, but they're really focused on in service design. When we talk about service design, since it's an intangible product, we have the 4 Ps, and you can look this up on the internet. You have the people, which are skills, organization, and experience of the people, and how the people are organized, the skills of the person, and their general experience. You also have the product. So what services we provide, what technology we use to provide the service, and what tools we use. Okay, and then the processes, what activities. I don't remember what RACE C is, but I think it deals with IT services directly, but you can look it up. Basically what activities and what dependencies we use. And then our partners, our suppliers, our manufacturers, and our vendor. So a service process matrix is a tool that I use to help me understand how we are, like how my service and how my department or my division is able to effectively provide a certain level of service. Like for instance, if I'm in a program where we are in charge of providing service on 4 products, I'd like to know how well we can do all 4 products. Okay. Or if it's organization-wide, I may want to make one for an organization, or I may want to make a service process matrix for an industry. I've done this before to show how well we stack up with industry in providing the same services to the same type of product. And sometimes you'll see arrows used to highlight relationships within a matrix. Like for instance, let's say you say fast food. I think this is actually on an example. I'm going to show you in a minute. So let's say you have fast food. You may have it in one section of your service process matrix, but then you may have like high-end fast food. You may have different types of fast food, like Mexican. You may have, any type of factor that can be a differentiator in how like for instance, let's say one type of food that you make uses different types of tools or requires different types of skills. You would want to use a service process matrix to help differentiate if you decide that you want to go into another type of fast food. You need to be able to understand how you're going to be able to do that. So it allows service operations to define overall operation strategy based upon the resources available. So I just have a little caveat here. When I do this, as we did in QFD, you should also do a voice of the customer and voice of the competition to understand, if we want to go into this other type of product, but is there a need for us to do that? Is the market saturated? Maybe we have to provide a certain niche. Maybe, it's kind of like, what's that place that makes a really great Chipotle? Chipotle just, doesn't just make burritos. They're not like Taco Bell. They probably, they could have went and said, well, we can enter the fast food Mexican, area, but we can't compete because Taco Bell is low cost, low to middle quality. They use a lot of standardization to make a very plain product. So they said, well, we're going to make a very high-end customizable product. So they found their niche and they went into it. Even though Mexican food may have been saturated, they were able to find their niche, and they said, okay, there's enough of the voice of the customer says, there's a big demand for this. And the voice of competition says, hey, there's no one doing this. So they jumped in there and they were very successful. They still are, from what I understand. So a service process matrix, and I would recommend that you do other analysis to understand the voice of the customer and the voice of the competition, so you have a better picture of your service offerings compared to both what the customer wants and what the competition provides. And this is a general service process matrix. Here you have, for instance, they got retailing. So you've got retailing with an arrow to warehouse and catalog stores, and you got retailing to boutiques. So, and this one they use labor and customization. A lot of service process matrices will use degree of labor, degree of customization. Customization usually increases cost, but it adds value by allowing you to address more customer needs, wants, and desires. Degree of labor, obviously. When we deal with degree of labor, this deals with how specialized the labor is. If, for instance, you can take high labor processes and you can specialize them in the low labor. What that generally does is you restrict the variety provided by your labor to perform a task, which can be a strategy if you just want to have a blueprint cookie cutter type process. But if you want to have your workers be able to absorb the variation from customers giving you many different types of requests in your service offerings, you may want to move away from specialization to more of a well-rounded type of labor, which is very high, obviously, because now the person doesn't know how to let's say make sandwiches. Now the person doesn't know how to make sandwiches, and he needs to know how to, let's say, make waffles, pancakes, whatever. I think hopefully you get the idea. So degree of customization, we deal with standardization. If we standardize the product, we decrease the amount of variety that we provide to the customer, which once again can be a good idea. If you're McDonald's, your brand value proposition is we make the same hamburger very well, and they give you some customization. So in some parts, they use a modular strategy called postponement very well, actually. I think they're one of the best, to do it, where they modularize by, they will standardize their offerings to a certain point, and then they will have high customization towards the end by adding different types of end products to make so they will cook the hamburger the same way, but once they want to add, but then they can add whatever the customer wants based upon what they offer, so that they can have very low customization in part of the process, but then very high customization close to the customer. I talk about that quite a bit in supply chains, but it's the same thing. It's a process function. I'll see if I can post something on postponement. I love the concept, and when it's done correctly, can be a game changer for organizations. And if you're interested in that and you want me to help out with that, let me know. I'll see if I can pull some stuff up for you. So it's called postponement. So degree of labor deals with the level of specialization of labor. Degree of customization deals with the level of standardization of the product. So, and then you just map it out right upon it. And this is very common. These two are probably the most common factors used. So service blueprinting is the last thing I'm going to cover here for now. Service blueprinting is used to provide a guidance on how a service will be deployed. Sometimes you hear these called swim lanes. You'll hear them called swim lane flowcharts. Six Sigma uses something like this. Sometimes if you're a Six Sigma expert, you may have seen something like this. But service blueprinting is all about, okay, now we know what we're going to provide. We know what the customer wants. We know how we're going to do it. So what we're going to do is we're going to specify the tools, physical evidence. I'm going to give you an example of that in a minute. The staff, processes, and support infrastructure needed to deploy this particular service. So in the case of fast food, when you know, okay, what's physical tools does the person needed to do? Do they need what kitchen utensils he may need? Does he need a stove? Does he need an oven? Does he need a microwave? Physical evidence is basically, well, I'll cover that in a minute when I go through the service blueprinting example. It's kind of, I don't want to confuse you here, but staff processes, how we're going to execute on these things. So really quickly, physical evidence is like the parts that we are going to use to do the service. Okay. Staff processes and support infrastructure. Do we need electricity? Do we need a building? Do we need a warehouse? Do we need an office? Needed to deploy a service. And usually we can go down to, it just depends on the service level that you do. Like, are you going to go down to the specific process level, or are you going to do at the strategic level? So blueprinting can be created using a process design process. Yes, that's kind of a process design process. So yeah, you can actually blueprint a service. In many cases I've seen where they may take an existing process, map it out using what we call swim lanes, and then you can use these different categories to map how that process flows. I've seen that done too. So it's an iterative process using several different methods. The first method that is used is the first pass. So we look at existing processes or similar services. This is key if we are going to expand our service offerings based upon existing services that we provide. So we take something similar, then we map that out. Then we will we'll create process maps or value stream maps to identify the steps of the new process. And then you can plop these down on your first pass to see how it's going to flow. Then you'll identify bottlenecks or critical weaknesses in the current design as your desired design applies to it. So this allows you to identify it before you deploy. Is it 100% accurate? No. Usually I recommend that you do these steps and then you do a quick run. Sometimes you hear them called dry runs. When I worked in fast food when I was in high school, I remember opening up a Foster Freeze. I didn't open it up. I worked for someone that opened up. And the first week we were there. We basically didn't have customers. We basically had people coming in, and we basically made free stuff. And all the owner did was basically watch how we did our job. And then he would say, okay, this week, this day, we're going to add, chicken burgers. And he watches the way the process relates, and he would go over and over again, slowly building upon our value proposition, so to speak, the product offerings, until he said, okay, I now know how my restaurant will be able to create all this stuff. So this is a type of service blueprinting where you may say, okay, I'm gonna make a first pass of a very general process. Then I'll map out each of the product offerings separately to see if there's anything that is required that I do not have in that main step. Then I'll address those. Then I may run it in a dry run. And as I said here, it should be updated occasionally to identify changes in processes or service environments. So for those of you who don't know what a value stream map is a lean tool that is used to identify quote-unquote waste in a system. In lean, waste is to be either deleted or it should be, what's the term? It should be, sometimes you have acceptable, like you have required waste. Like for instance, if you may have waste of, the product has to drive 1 mile between warehouses, it may be acceptable because the alternative may be flying at 300 miles. So sometimes, some waste is acceptable, some isn't. But we always try to delete the undesirable waste. And it has, the mood of the 7 types of waste. I'm not going to go through that here. I may create a lean discussion to go over it in more detail. But bottom line, these should be done occasionally, because things change. Sometimes you have changes in your team. People may leave or quit or whatever. You may have changes in your equipment. Sometimes equipment wears down. Sometimes you may have started with 3 stoves, now you're down to 2 stoves. And you may have your processes may have been compromised by, Deming talks about worker training worker. Sometimes people take shortcuts in processes. They may not follow the book. So you want to map this out to identify these changes so that you could update your service blueprint, and also so you can also update how it needs to be done, taking into consideration these changes. So this is an example of a service blueprint, and on the side you have physical evidence or a communication channel, customer actions, frontline staff actions, behind the scenes staff actions and support, and systems stuff. So these relate to the factors that I mentioned earlier, and then these are the different parts of the service blueprint. The web kiosk, the service point, presentation space. These are the physical offerings, what we require, the infrastructure required to do certain things. So you can map all this stuff out. This comes from a tool, Learning Space Toolkit. It's a pretty good website. I was looking through it before. So you can look at these and you can see how your current service design relates to these various factors that have been identified as something that we want to maybe you want to create a new process or a new product offering that may take all this into account. So you can do this. I've also seen, I don't think I have it. Let me see. Okay, I do. So I've also seen this where this is more of a swim lane where you have the physical evidence. This is what I've seen most. Well, this is what I've used most, where you have all the different steps in your process. Then these are the different factors that we mentioned earlier, or factors that apply to your particular service offering. And you just map it. You see where it all fits in here, and it all flows down until completes next order, support specials. So This real-time board, I think, is a tool. I haven't used it much, but I saw some examples online where real-time board is a tool for making service blueprints. So feel free to look at it. It seems like a pretty good thing. So in general, it's basically the same as a swim lane chart. Well, it's similar to a swim lane chart. Sometimes you'll see these spread out over more, so you can see more concurrence between steps, you know, in a time sequence. Like let's say if this one happens first, you may have this category may be spread out, so it shows the rank of these 4 within certain time periods. You can do that too. I've actually seen that before. When I helped redesign a repair facility, I had seen this done. Now it makes it very long and lengthy and very complex, but you can do that. So that's what a service blueprint does. It allows us to understand how our process will flow. And if you want to create a new process, this allows us to understand how our new process will flow based upon our current design. So the book talks about this. It's actually pretty good about this. I was reading it earlier, and it's actually very good at discussing service blueprinting. So if there's any questions, as always, bring it up in the classroom. I'm more than happy to answer whatever questions you have. So there were no questions provided during the week, so I will leave it at this. And I will, if there's any questions during the week, I will answer them during the week in the discussion questions area. Once again, the first milestone is due this week. So the rubric tells you what is expected in this week's assignment. Please feel free to let me know if you have any questions, and I will be more than happy to help you out. And as I said before, if you want to send me what you have and have me review it to give you some ideas or some suggestions, or maybe you may be stuck on an idea, let me know, and hopefully I will be able to help you out. So until next time, I will talk to you in class. Thank you very much.